Good morning, good afternoon. Thank you for joining. Before we get started with today's webinar, I just want to go through a few housekeeping points. The session is being recorded and you will be shared it by email after we're done. You should be able to check the attachments tab here in BrightTalk to get the presentation and the research report that we're talking about. And if you have any questions as we go, please do use the Q&A tab. And if we've got time at the end, we'll get to go through them. But now to actually start, my name's Ant Newman. I have the honor of leading a research project here at SpectroCloud called the State of Production Kubernetes. And that's what we're about to spend the next 30 minutes or so going through. So my goal for the session is to give you some real data that you can use, whether it's to benchmark yourself, to justify any budget for some projects you want to run, or perhaps even give you some ideas of new things you can go and investigate. So the plan for today, I promised in the event description 5 key insights, and that's what I hope you're going to get. We're going to cover, first of all, complexity and the state of Kubernetes adoption and how it's multi-everything. We're going to run through the consequences of that and the pain points that ops teams face. We're going to move on to delivering a great developer experience in the world of platform engineering and Kubernetes as a service. We're going to move on to app modernization and how we look at modernizing legacy virtual machine workloads. And lastly, going to the edge and what the future holds for that. Everything you're about to hear came from a research report we conducted a couple of months ago with an independent research house called Dimensional Research. We've been working with them for 3 years now. So it's a well-oiled machine. And they ran an in-depth survey with 333 Kubernetes professionals. So that's what they've got in common. They all work with Kubernetes in production, whether practitioner or decision maker. We made sure we represented all kinds of different industries, including the public sector, all kinds of company sizes from 250 employees up, and all kinds of seniority and role specializations from ops to dev, from individual contributor to C-level. So we really made sure to get a picture of the whole Kubernetes landscape. And we followed up the quantitative survey with 10 really in-depth telephone interviews, which gives us some juicy quotes that you'll see throughout the course of this deck. We also made sure that we tried to do some continuity with previous year's studies. So there are some year-on-year comparisons you'll see here. Obviously, we've evolved our agenda as the landscape evolves too. So let's get started. This is the first topic, complexity and multi-everything. Now, Kubernetes has a reputation for being not only powerful and flexible, but also complex. It has a steep learning curve. It's also a bit of a meme, actually, just how hard Kubernetes can be. And I love this quote that we've got here on the slide that sums up the love-hate relationship between tech professionals and Kubernetes. It's from the most frustrating, painful, and beautiful thing I've worked with in my technology career. Now, that's Kubernetes in and of itself. Kubernetes becomes even more complicated when you run it in enterprise production at scale. And the truth of the situation is we have that scale enterprise adoption today. So we're only asking, obviously, people who are using Kubernetes in production. But when you're using Kubernetes in production, chances are you have more than 10 clusters. 56% of our respondents said they had more than 10 clusters today, up from 49% who reported that last year. They run Kubernetes in multiple different environments, whether that's hybrid, multi-public cloud, virtualized data centers, edge, bare metal. It's a multi-environment thing. And as a result, 83% also said they used multiple Kubernetes distributions today. The last point on this slide is what we call add-on layers or integrations. Now, these are the things that make up the reality of a production cluster. So things like service mesh, monitoring, security tools, all those other things that don't come necessarily with your base Kubernetes distribution, but they're essential to making applications work. So 72% of our respondents said they had more than 5 software integrations or add-on layers in their cluster. 39% said they had more than 10. So this is a degree of complexity that we have here. You know, Kubernetes is more than just the distribution you use. We also found the line along the bottom, those respondents who had more clusters reported more of everything else, more diversity, more complexity. We also found that almost everybody expects their scale to grow and therefore, by implication, their complexity to grow. So you see here we have 4 questions about how do you expect your organization's use of Kubernetes to change over the next 12 months. The green bars and the blue bars are growth. So the vast majority, around 80% of the respondents, said that they would be building new applications for Kubernetes, migrating existing applications to Kubernetes, increasing the number or size of their Kubernetes clusters, and have more development teams deploying to Kubernetes. This is a story. We can't necessarily make any predictions about the exact size or complexity, but what we can say is there is an expectation of growth and of complexity. And that is important because the scale and complexity of Kubernetes today is already proving a challenge for operations teams. We asked a question here: do you suffer issues caused by the interoperability of elements in your Kubernetes software stack? That's why I was talking about the integrations or add-ons on the previous slide. Now, 75% said that they suffered issues. That was up from 66% last year. Those who had more than 20 clusters were 3 times more likely to say they regularly suffered issues. That's a problem. We've got a complexity causing actual application downtime or other issues that users and customers feel. Now, along with that, 40% of our respondents said that they lack the skills and headcount needed to manage and support Kubernetes. That's up from last year, not a huge amount up, but up. And that whether you take it as a skills issue or you take it as a headcount issue, that still paints a picture of teams that are not able to do what their mission is. And the reason for that, we asked, where do you spend too much time? Where do you spend not enough time? And we gave them a whole long list of responsibilities. This is a tale as old as time in IT. This is not specific to Kubernetes, but we see the same story play out here. We spend too much time on troubleshooting, patching, upgrades, building and deploying new clusters, the kind of grunt work, the routine tasks, and painful reactive tasks. What they said they don't spend enough time on is innovating and experimenting with new technologies, strategy and planning, monitoring and reporting, things that are strategic and really position ops or platforms teams as partners to the business, whether it's actual business teams, line of business teams, or whether it's the development teams that they serve. This is an issue. We asked, what do you think is the answer to this? And we gave a whole list of options: moving to bare metal, bringing in managed services, reducing headcount. But the 2 answers that really stood out, number 1 was automating manual processes. Shouldn't be a surprise to you guys. 56% of our respondents put that in their top 3 solutions. That's great for us here at Spectra Cloud. We produce a management platform for Kubernetes that does a lot of automation, so fantastic. I do want to talk about that second choice, though. The second choice was simplifying the infrastructure software stack. So going back to that slide I showed previously about all the different distributions, all the different software integrations, and the fact that the more clusters you have, the more different things you have in your clusters. So nearly half of people said they wanted to simplify the infrastructure software stack to solve this problem. Now that, to me, I'd like to push back on and say, if you want to experiment with new technologies, if you want to give development teams the technologies that their applications need, then you should be free to do so. You shouldn't be restricted into a highly opinionated platform that says, well, we only have one service mesh here, or we only have one runtime, whatever it might be. So this feels to me like cutting off your nose to spite your face. But to automation, there are a couple of quotes here on the slide that I think really put a bit of nuance to this issue. The first is, well, how do you get this ball rolling? If you have no time to investigate and think strategically, how do you put in place a new platform that automates these painful issues? The second is, if you do put in place a technology or a process that automates, well, someone needs to own that and maintain it. It's another layer of abstraction. Actually, in a sense, it can exacerbate the issues, but someone's got to own it. And this is where we get to the next section that I wanted to talk about, which is the developer experience and Kubernetes as a service. So if we've just come back from KubeCon and platform engineering continues to be all the rage, this is about how do you give the developers who are writing the applications that your business uses, how do you give them the experience that they need to maintain feature velocity, maintain code quality, and support where your business needs to go. None of us build clusters and operate them for its own sake. It's all there to support the applications. So we asked a very simple question with a very messy answer, which is, when you are wanting to deploy an application to a Kubernetes cluster, what's the typical approach? And we gave a whole load of different options. And the number one that 25% of people picked is code is deployed through a CD pipeline, which triggers the creation of a cluster. Fantastic. CI/CD is the modern way to do it. Even so, that's not a majority of people answering that option. The rest of the options were all more or less neck and neck. And if you read through the text, not necessarily now, but when we share the recording, there's a whole load of different dimensions in here that are all balanced. So is it developers self-serve clusters, or do they ask ops to build a cluster for them? Are they persistent clusters that new applications or new versions of applications get deployed to, or do you build a new pristine cluster each time? Do you use, for dev, test, staging environments, do you use ops controlled infrastructure, or is it just a public cloud account that you as a dev team have, or even local machine? And every single one of those options got a good number of votes. Now, you could just say, well, that's because every business is different, and there's a choice that's right for you. But actually, we believe, and some of our respondents gave us a strong story, that this is actually experimentation. It's a swinging pendulum of trying to find the right approach, because they all have pros and cons. So there's a great quote here which talks about this cycle. There's a cycle of developers feeling like they're being slowed down because of a ticket or waiting for a cluster, so they try a self-serve approach. But then teams that are supposed to write code to add value are doing operations tasks they're not suited to, and the pendulum swings back to operations to deliver clusters. Now, if you've been in this tug of war or inverse tug of war where nobody wants responsibility, this should be familiar to you. And we asked some questions that I think reveal a little bit more around that issue. So 92% of people agree that app developers should spend their time on features, not managing infrastructure. Fantastic. Surely then it's ops' job. Well, 82% said it's difficult for ops teams to give every dev team a cluster tailored to their preferences. Okay, so ops is not doing a great job in terms of delivering what devs want. Also, 51% said their devs are often unproductive, waiting for clusters to spin up. So that whole metric of how developers are delivering value in terms of feature velocity, we're slowing them down. But at least if ops is delivering it, then we make sure we've got governance. Well, 37% said they have inconsistencies between dev, staging, and production environments. So going back to what we're talking about issues in the cluster, if your test environment is not the same as your production cluster, then you can't guarantee that the application is going to perform the same way. So we've got a mess going on here, and there's people are clearly looking for an answer. This is obviously what platform engineering as a discipline is supposed to be all about. How do we find a way to serve internal customers with speed, consistency, and flexibility all at the same time? So there's a whole host of tools that have sprung up in this vibrant cloud native ecosystem. I've just pasted a few random screenshots here on this slide of Scaffold, DevSpace, Ambassador, Octato, Acorn, and they all approach different areas of the problem, but they were all identifying the same problem space, which is that developers struggle with working with Kubernetes. So we asked, do you use one of these tools? There's several different ways to cut this data. First observation, 95% of people have heard of some of them. So that's great. It shows people are engaged in the community and looking around at solutions to their problems. 62% of people are using one today in some capacity. And actually, the organizations with more developers are more likely to be using one of these tools. On the other hand, 20% of people nearly are still holding back, even though they've heard of these tools, haven't tried one yet. 14% have tried one, but it didn't work out. Too immature, didn't solve the problem, extra tools actually make things more complex, whatever it is. Our prediction is that this is going to be an area that sees a lot of activity over the next 12 months, particularly as AI rears its head and all this Copilot functionality comes in to try to help with troubleshooting or configuration issues. Regardless, I think we've got a very clear view here of the need for platform engineering and for tackling this intersection between devs and Kubernetes. We've talked about deploying applications. What we haven't talked about so far is what about existing applications? So we asked organizations, what are they doing with their existing virtual machine workloads? We know that from last year's survey, a question we didn't repeat, that the vast majority of those that are using Kubernetes in production say they are 100% committed to Kubernetes, to containers, to cloud native practices. It's where they are building and deploying new apps. It's where they plan to migrate existing apps to. But every individual we spoke to said that we've got loads of VMs. We can't necessarily refactor, migrate them all into containers. And the result is it feels crummy, like this quotation on the slide here. And we found then the consequences of that are, well, I'm a stretched, overworked ops team. We saw that earlier on. Now I'm maintaining 2 sets of skills, 2 sets of practices, 2 sets of infrastructure to keep VMs running along on one side and Kubernetes and cloud native running on the other. There's clearly a pent-up demand here. 85% said they are migrating if they can. 86% said they want to unify containerized and VM workloads on a single infrastructure platform. 23% went further and said that if they were asked to pick the top 3 considerations they had when choosing a Kubernetes management tool, 23% said that support for VM and containerized workloads was in their top 3 requirements. That's quite extreme when you're thinking about like a Kubernetes environment where maybe it's support for bare metal or edge or a developer environment. All kinds of different things you could ask for, but support for VM and containerized workloads was up there. You may have heard of a tool called KubeVirt. This is where I deviate ever so slightly from our own research, just to show that there is a tool that promises this. And if you were monitoring the socials over KubeCon time, you'll have seen a few mentions of KubeVirt. KubeVirt hit version 1.0 recently, a couple of months ago, after 7 years or so of development, and there's a noticeable upward trend in searches for it. This is the Google Trends down in the bottom left, and a few fairly noticeable individuals in the community have called out KubeVirt as one of the trends to watch. This is something we have built into our product, so it's on our radar as to, well, are people aware of the product? Are they using it? I'll come on to the last trend now, and this is a big one for us. It's an area where we think there's a huge amount of potential for our community, and also a huge amount of business value. And this is edge computing, edge Kubernetes. So we've asked in previous years, where are you doing Kubernetes? Public cloud, data center, edge. About a third of people said we are doing Kubernetes at the edge. But what does doing Kubernetes at the edge mean? Does it mean you are fully deployed at scale, all there, we're done? Or does it mean we have one box with flashing green lights on in a lab somewhere? So this year we asked a more detailed question of, well, what does that mean to you? And the shape of this chart is very interesting to me. We found that 49% of our respondents are doing something with edge. So that's up from last year overall. But only 7% are fully in production at whatever scale means to them. That might be in 10 retail stores or 1,000 different well sites, whatever it might be. Only 7%. But the vast majority are on their way there, partially deployed, in a trial, or working on their plans. Only 7% of people said they weren't considering, which means 93% of people are. Now, we believe that this is a sustained future growth. We asked this year, do you expect growth in your adoption of edge Kubernetes? Last year, it's 12%, had strong growth. This year, that spiked to 21%. And the reason for that is because clearly edge is strategic. Now, we asked, why are you investigating edge? And if you look at the top, middle, and bottom of this chart, I think there's a few different groupings here. I'll start at the top. The number one reason for investigating edge is for business process improvements. Now, this means revenue up, cost down, risk down, whatever those sort of basic business drivers are. And so we have one customer, for example, that uses edge to monitor factory production lines. We have another that's monitoring oil pipelines. Now, this means that the edge deployment will have a direct impact on the business's bottom line. That's not going away. The second biggest driver is new connected solutions to offer to customers. So we have, again, a customer that makes dental equipment. They're using Kubernetes at the edge to power scanning equipment, which dentists use to get immediate imaging results for customers, something that if they're in a rural location, might be impossible with sending that data to the cloud, or slow. So they're finding a way to generate revenue from these new products. And I've got another example on the next slide. The stuff at the bottom of this chart is just as important to me here. I was conscious when I put these options in to see whether they would trigger a response. But one is because our competitors are. Like, we've seen our biggest rivals start to do stuff at the edge, so we're going to look at it too. Apparently, that's not a big case. 14% picked that option. The other option is we're the IT team, and we've been asked by a line of business. They've been putting pressure on us. That would suggest, first of all, a reactive mode, but also that, again, it's just because someone's asked us to. Both of those options got relatively little response. That suggests that there's a really strategic view going on here. Now, the third block of responses is in the middle, and I think this is just as important for explaining why edge is going to be sustainable in growth. The first is that sometimes it's driven by compliance and security. If you're gathering sensitive data, for instance, medical data, it can be safer to leave that on the device than send it over the network into potentially a different jurisdiction up into the cloud where it needs to be managed. Another reason is we have applications that can only function when deployed at the edge. If you are doing real-time vision analysis, then having a 200 millisecond delay could render this application useless. Or if you're doing it in a remote location where there isn't connectivity at all. When the business embraces applications like this is where edge is the only answer. And there's one more big driver, which I haven't mentioned yet, which is AI. So we asked in several of the interviews whether this was something that was motivating their use of edge. And this is a financial services company that's responding here. We're seeing real potential for doing AI and ML applications on edge devices. And if you have been to some previous KubeCons, you may remember we did a session with Tavel, an agritech startup. They're doing computer vision on flying robots to detect ripe fruit and pick it. And that is running on a Kubernetes cluster out in the orchard. So AI is real. It's happening. A lot of our customers are looking at it. And when you're doing something like computer vision, it requires real time. It's not just our customers and our survey respondents that are spotting this trend. This is a screenshot from the Gartner Hype Cycle. Gartner is predicting that deep learning will be included in 65% or more of edge use cases, up from less than 10% in 2021. We've actually gone to the liberty of securing a complimentary reprint of Gartner's 2024 edge predictions, which you can grab from that URL, to sort of show that there is a lot of demand driving edge. But not just demand, there's also some challenges too. And if you see on this chart, edge AI is slipping down into the trough of disillusionment, beautifully named. That you could say is driving edge 2 in general. So we asked, what are the challenges you face when you're doing Kubernetes at the edge? And what I've shown here on this chart is a comparison of the top 4 challenges in 2023 and how those showed up in 2022. As you can see, big spike in these 4. Number 1, compliance and security. This is a very easy answer to pick. Naturally, when you have computing, storage, AI models, sensitive customer data deployed in potentially an unattended site or a site where there isn't proper security, like in a retail environment, for example, there is a risk of tampering, there's a risk of theft. And how do you keep that device's data and its access to other systems secure? Especially when that data might be governed by compliance requirements, for example, in a medical scenario. The next three challenges are really closely related, in my view. So once you have 1,000 devices out in the field, they're going to be there for 5 years, maybe 10 years if you're in utilities, for example. Those devices need monitoring, patching, upgrades, configuration changes, troubleshooting, fixing, the world of data operations. Now, you could try doing that remotely, but in some cases, you can't rely on connectivity. That's one of the downsides of deploying in potentially rural environments or air-gapped environments. And so then you need to resort to field engineering visits. Literally send an engineer out to poke at the box and plug a USB cable in. Now, that's fine if you're doing it in the lab or you've got a pilot deployment at one of your main sites. But if you're doing it at scale in a truly distributed sense, field engineering becomes a huge blocker. And it becomes a huge blocker that can slow down your deployment if you need to manually set devices up. And it can cause problems if you say you've got devices that are installed on client site and one of them goes down and you've got a 2-week delay till the field engineer can get to site. So these are the kinds of issues that organizations need to tackle when, as this mid-sized transportation company say, now we're figuring out the issues of enterprise management and scaling. This is where Edge is today. That brings me more or less to the end of this whistle-stop tour of our data. I want to give you a link to, as you can see here, this is where to get the report, which contains all of this data and more. I did also want to flag up a few topics that we've covered today and a response to them. So apologies in advance for the mild sales pitch. If you're struggling with that day 2 operations, with the ops team struggling with troubleshooting and patching and upgrades, we have a management platform that can do a lot of automation, which came up as a solution. So do check out our website where we have a data operations page. If you are looking at giving your developers consistent, fast, easy, personalized access to clusters that look and feel just like production clusters, we have an implementation of vCluster called Pallet Virtual Clusters. You can check that out on our website too. If you are looking to implement something like KubeVirt to manage VMs alongside containers on your Kubernetes clusters, then we have Virtual Machine Orchestrator, an enterprise-grade implementation of KubeVirt. So you can check that out. And of course, we have our Edge product, including our recent Edge AI announcement. So you can check that out too. I'm going to take a quick look at the Q&A box and see if we have any questions from the crowd. There are just a couple in here. Will you be doing this research again? Yes, twofold. We will be doing this research again next summer. Hopefully, we'll be doing a very similar set of questions, larger responses. We'll be able to do more longitudinal tracking. We also plan to do a dedicated report specifically on Edge, so starting early in the new year. Second question I see, did the research ask about bare metal? If you saw our session with Super League Gaming at KubeCon, which was a double sellout, I guess that might have prompted the question. Yes, we did. And bare metal is still somewhat of a niche thing. We saw adoption go from 20 to 25% of people say they're using bare metal in some capacity, but only 11% expected strong growth. So I think there's still some challenges around that. We could say that the Broadcom acquisition of VMware is certainly encouraging some customers that we've been speaking to look at reducing their dependence on VMware, and adopting bare metal could well be part of that. The third question, and I think final question, what are the most common environments for deploying Kubernetes clusters? So I showed the chart about how many have Kubernetes in multiple environments. The number one was virtualized data centers. So good old traditional DC on-prem. The second, just behind virtualized data centers, was AWS, and third was Azure, so Microsoft. We didn't specifically ask about whether it's the IaaS or managed services like EKS, but those are the top three. Google Cloud, a little bit down from that. That looks like all of the questions we've got. So just one final thing to say, which is on behalf of everyone at Spectra Cloud, thank you very much for taking a tour through this session. Do check out the report. It has more data points in it, and look forward to seeing you next time. Thank you very much.